We present AuraRing, a wearable input device that enables high-fidelity finger tracking. AuraRing uses custom electromagnetic tracking to precisely and continuously estimate the 5-degree of freedom pose of a ring from a wristband. This enables freeform and subtle input for wearable platforms like smartwatches or mixed reality headsets. AuraRing relies on a short-range and low-power AC electromagnetic tracking technique. The system consists of a wristband, which contains 3 sensor coils, and a ring, which acts as a magnetic field generator. To minimize the size of the ring, the magnetic field is generated using a thin wire coil that is tightly wrapped around the surface of the ring. The ring generates an oscillating magnetic field around the user's hand, which is measured by 3 rigid sensor coils in the wristband. As the user moves their finger, the voltage induced in each of the sensor coils changes, resulting in the measurements that AuraRing uses to reconstruct the pose of the ring. In order to perform this accurately, AuraRing uses a one-time calibration procedure to empirically learn parameters of the sensor model, which describes how a given pose manifests as sensor measurements. Pose reconstruction in runtime is then accomplished using either a nonlinear optimizer or a closed-form neural network. AuraRing focuses exclusively on short-range tracking in the range of 10 to 15 centimeters. It has a sensor resolution of 1/10 of a millimeter and a typical accuracy of 4.4 millimeters. This enables applications like freeform drawing or handwriting. Thanks to a high bandwidth and data rate, the system is also able to detect high-speed events like taps of various intensities. In this example, users tap on the left and right very quickly, and the AuraRing can give immediate feedback due to their broadband spectrum and higher energy. By leveraging a kinematic model of the hand, AuraRing tracking can be used to drive an inverse kinematics model to estimate hand pose. This can enable interaction with virtual objects for mixed reality headsets. By combining AuraRing with an arm or wrist tracking solution, items can be selected in absolute coordinates. We envision AuraRing as a way to extend the interaction modalities for many use cases. AuraRing enables precise continuous finger tracking, which can be used to better interact with smartwatches which have otherwise limited input areas. As a magnetic tracking device, AuraRing can be particularly useful for subtle input as no line of sight is required. In augmented and virtual reality applications, AuraRing can improve immersiveness by allowing for the detection of in-air actions such as taps, swipes, and subtle gestures. A user can select and manipulate virtual objects with their finger.